we can finally start to look at how bits of information go across the wire after the switching and routing portion of communication is established. Now, TCP isn't restricted to layer 2 or layer 3. It's a protocol or delivery method of data, if you want to look at it like that, for particular sets of information. How we actually get there is sent by the layer 2 and layer 3 part of the actual packet, and then the protocol use or the actual data overall is starting to get towards the end of that packet to where we can communicate between systems of useful information. As far as stuff like web pages, files being sent, etc., etc. So that's why we're focusing on the TCP and starting to get into those other protocols. Now, in the next skill, we're actually going to be getting into UDP and then follow up with ICMP and then getting into some actual data payloads. But the reason we're starting with TCP first is because it has a very unique set of skills and it has a very unique way to send that data across the wire. More importantly, we use TCP when we want actual reliability in our communications. And this is done with the actual TCP handshake. Now, this does also have a nickname to it. It's called the three-way handshake. And that's because there are really only 3 steps to it. Now, in our example here, Bob is going to go and contact the server that Lois has. Lois? Yeah, I'll get it. And say, I would like to talk with Lois on port 23. Are you open? And this is going to be a SYN flag. And we'll go more into these different types of flags here in just a little bit. But it's going to have a sequence number of 5 on it, noting that where we can find this in the actual stream itself. And then the server reports back saying, okay, Bob, I am open on port 23. And it's going to send a SYN plus an acknowledgement, or ACK. And then it's going to, that ACK is going to have a sequence number that follows the original sequence. So sequence 5 for the SYN, acknowledgement number 6 for the SYN-ACK. And then this packet overall has a sequence number of 103. And then once Bob gets that acknowledgement, he's going to acknowledge the acknowledgement. So those of you that have military experience, you totally get what's going on here. So we're going to acknowledge the acknowledgement with acknowledgement 104, following the sequence packet of 103 that came over from Lois. And then that packet overall is going to have a sequence number 6 because it's following the initial request or the original SYN packet that Bob sent over to Lois and the server to begin with. And this is basically the breakdown of the three-way handshake. So any communication that starts on TCP, you should see this three-way handshake between the client and the server. So 2 packets from the client, 1 from the server. Now you'll see a little bit different of a series here when we start getting into the actual termination. And you heard right, there is an actual process of termination in a TCP communication because it's not just let me drop connection like it is in UDP. Now, yes, there are cases, and we'll discuss those after we go over the actual termination process itself, where sometimes connections just break. Like for those that grew up on dial-up, sometimes the connections just dropped and there was no way to actually send a packet or an acknowledgement or a flag overall over TCP to get back and forth. So it just drops. And there is a flag for that as well that both get after a particular timeout. But when we look at a standard TCP termination, there are definitely a few steps to follow, and we're going to break them down. So we got our client Bob, who is trying to do a TCP session with Lois. Lois? Yes, Lois. On an actual server. Now, there's a lot going on back and forth here. When Bob initially says, okay, I'm done with all the data that I'm using on this server and I don't want to do anything else, he's going to send a FIN with a sequence number over to the actual server that Lois is holding. And then the server is going to acknowledge all of this with an ACK or acknowledgement. And that acknowledgement is also going to have its own number, just like the sequence number. And these numbers will play a big part in establishing which packets go with what types of streams and who did what. Because in TCP, we remember that we have sequence numbers, acknowledgement numbers, and everything logged with those numbers to tell us which packet is next, which packet is first, which packet is in the middle, and how we can expect that order. So when that ACK comes over and says, all right, I received your termination request, we got ACK, ACK 91, sequence 207. Well, it's also, the server is also going to send a second packet back over and says, I have received all the data sent. So this is separate from the actual termination request. It's just making sure that with that request, all the data that you initially required was being sent. And so we're getting our fin and our sequence number 208. Now, Bob is actually going to close everything out from his client over to the actual server. And this is done with an ACK is acknowledged. I've gotten everything from the server. We're going to start closing everything out. And then we're going to acknowledge packet 209, which is finishing up that termination request. You'll see that it goes 207, sequence 207, sequence 208, and then acknowledgement 209. And then the overall sequence number of this packet itself is going to be following the initial sequence of the fin request that Bob did originally to begin all this. So it started off with sequence number 90 on that fin flag, and then it went down to sequence number 91 when everything was acknowledged. And overall, this is how a TCP session is terminated. And when we get into the packets, we'll definitely see where all of these different ACKs and fins and flags and all these numbers play a big part. But we do need to establish that there is an actual initial handshake and an actual session termination, because that leads us into some of the problems that we can run into as network analysis teams going out there trying to make sure that nobody's trying to insert anything bad. All right, so you've heard me talk about these different types of flags and how they play a part of the three-way handshake and the actual termination of a TCP stream, but what are these actual flags? And the reason I'm bringing them up now is because it was easier for me to learn the handshake and the termination process and then learn the flags later. So I'm trying that here. If not, leave a comment, let us know. I will change this. Now our first flag is going to be the send flag. You'll see this more often than anything else, and this is a synchronization flag. It's the first step of any connection establishment, specifically in our three-way handshake. And if you're doing a packet analysis, this should be the first type of flag that is sent between client and server or back and forth. So this should start everything off for us. If you see anything starting off, let's say another flag, cause for concern. And then you have your acknowledgement flag, which we've also talked about as well. It's used to acknowledge packets that are successfully received by the host or the destination. And we've seen that already in our examples where a send would start off our three-way handshake and an acknowledgement was sent in return to give us that, yes, it did in fact send over there and synchronize. Now with each ACK and send flag, there's going to be a sequence number. And as we saw during the handshake and the termination, those sequence numbers rely on each other to determine which packet comes next and which packet should come next. All right, we saw in our termination process, we had a fin or finish flag. It is used to represent the connection terminating. So, ta-da! Now we're going to get into some of the less common flags that we see that we've already kind of hinted existed. And that is, let's say we have that connection dropped from the actual client or server over that dial-up connection that I had back in the day. And you would see a reset flag. And it's used to do an abrupt termination or any kind of termination that is not done in the proper form of the TCP termination process. We also get the occasional urgent flags. These indicate that data contained in the packet should be prioritized and handled urgently by the receiver. Now, this is kind of crossing that alley into services that we will get into later or that you can learn about here on CBT Nuggets. We've talked about QoS, quality of service. And the urgent flag here can indicate whether it's going to be an urgent flag or not. If it's urgent, then the priority is going to be given to that packet and eventually that stream as well. And quality of service is an indication of how that urgent flag gets set based on the program. We also have push flags. It's used to request immediate data delivery to the receiving host without waiting for additional time to be buffered on the sender side. So basically, hey, you're going to get this whether you like it or not. And the reason that we're pushing it is because we know that the connection is stable enough to do so because we already have a three-way handshake established between us and you. Now, you may be wondering where I'm getting all these flags from and the information that we're using for our TCP breakdown with all these bits of information. Well, I'm glad you asked, and I'm putting it on screen now because it's in our book for the supplemental materials. I have it on screen now, and we're taking a look at page 3, and this is the actual packet breakdown of a TCP header. Now, we'll definitely go more into this on the next nugget, and the nuggets following, but I just wanted to introduce this to you and let you know that we will be using this in the following nuggets to break down our packet just like we did in IPv4 and IPv6. But pay particular attention to byte offset 13, and that's where our flags are. And you can see down at the bottom that I have flags written there as well too. It just so happens that byte offset 13 is where those flags are at inside the actual TCP packet itself. And just like any other bit of binary, because byte offset 13 is 8 bits of a binary, that flag is either going to be on or off. So it's not necessarily that we have to convert it to decimal. We have to make sure that we read that byte right there in binary in the raw form to see what individual bit is on or off. Okay, well, that's a lot of explanation and getting into the introduction of TCP. But in the next nugget, we need to start seeing where this is coming into practice at and what it's actually being used for. So I hope this has been informative for you, and I'd like to thank you for viewing.